Welcome back. In this video, we're going to apply that skill of simplifying radicals to the overall concept of solving quadratics by square rooting. Solving by square rooting really only works if you have an x squared term and a constant term, okay? It only works when you have that, when you don't have the x term. Otherwise, we're going to get to that later with a more complicated way of solving. But when you have the x squared and a constant, you can solve by square rooting. The process of solving by square rooting, the first thing you want to do is get the x squared term by itself. So in this first example, to get the x squared term by itself means adding that 81 to both sides. Sorry, add that 81 over to the other side. And now that I have the x squared term by itself, now I can square root both sides. Square rooting the x, or the x squared, just leaves me with x, okay? Square rooting undoes a square. And the square root of 81, we know, is 9. Now, a big thing to not forget is we need two solutions. When you square root in an equation, don't forget you are getting a plus and a minus. So make sure you don't forget that when you're taking the square root of a number. All right, so let's apply to the next one. Again, I need to get the square root by itself, so I'm going to add the 32 over. I'm going to square root both sides. So that's going to give me x equals, can't forget my plus or minus. Now the 32 is not a perfect square, so it's not going to give me an exactly nice number, but I can pull something out. I can still simplify that, which is why we practice our simplification skills before. So it actually breaks up into 16 times 2. Now in this lesson, I'm not going to show all that calculator work, but again, you should be looking at that list of perfect squares, and you can search your calculator to see which one divides 32. And in this case, it turns out to be 16, and we know what the square root of 16 is. We know that that is 4. So we know this simplifies to plus or minus 4 square roots of 2. Never, ever, ever forget that plus or minus symbol. Looking at this next one, same story, okay? We have the x squared term and we have the constant term. So I need to add the constant term over. But in this case, I still have to get the x squared term by itself. So now I need to divide both sides by 2. Now that I have my x squared term by itself, now I can square root both sides to give me just x. Never forget your plus or minus. Square root of 25 is actually one of our nice perfect squares. That's just going to give me plus or minus 5. And on our last example, same story. We have our x squared term and we have our constant term. So I can solve by square rooting, meaning I can add the 36 over. I can divide by 3. And now I need to finish solving this. So now that I have the square root by itself, or the square by itself, I can square root both sides. That'll give me plus or minus square root of 12. Well, 12 is not a perfect square. However, I can pull out a perfect square. So if you look at your list of perfect squares, hopefully you can see that it splits up into 4 times 3. And again, I'm pulling out the 4 because it's a perfect square, and the square root of 4 is simply 2. So my final answer is going to be plus or minus 2 square roots of 3. So a pretty basic setup, but you just have to remember how to simplify those radical expressions. So I thank you for joining me, and come up. Um, if you have this finished and have any questions, please just make sure that you ask.